All right. Yeah, audio working. I can barely see you, but you're there. Welcome to the Spring Framework. Well, I'll tell you a little bit about the session in just a bit. It is a Spring Framework 4.3 session, but it's not a what's new. It's a different storyline that I have been using several times, and a variation of this I'm going to present today. We're going to do a little bit of a design review. Basically, the essence of the Spring component model, a selection of highlights from the Spring component model in source code. So it's basically a source code only presentation where some more recent Spring Framework features are just going to shine through. So it is a storyline that basically takes you from the core of the component model to the more recent endpoint models, like MVC obviously, but also the messaging endpoints and others, and explaining several Spring 4.1, 4.2, 4.3 refinements along the way. So we're talking about the 4.3 level of the framework, but it doesn't actually matter as much. So it's part of the point of the story. If you look at the present Spring Framework component model, you shouldn't constantly think about when things have been introduced. It is just there now for you to use it. Whether it's a 4.1, 4.2, or 4.3 feature should not really matter that much, except for transitionary phases. But in the end, it's all a unified component model arrangement following some design principles that we are applying very consistently. So much for a little bit of an introduction. I suppose most of you are somewhat familiar with the core component model, right? Let's start with the inverse check right away. Who hasn't worked with annotation-based components in Spring much at all? Anybody not really experienced with annotation-based components? That's perfectly okay, right? I mean, you're going to get into it in some form, at least. Who's working, maybe a little bit of version checking, who's working with Spring 4.2 right now already? Like for the actual production work. And 4.1 at the moment? Older than 4.1? How old? I'm not going to check. It will probably be frustrating. I don't. 2.5 somewhere. So some of those things actually date back to 2.5, but obviously they've been refined quite a bit along the way. All right, let's get into it. We're not going to spend a ton of time reviewing the core component model, but I'll start the storyline here. So what we're seeing here is basically straightforward Spring component implemented in the Java language. It is a Java class, obviously, but that's actually already a key element of the story. A Spring component is fundamentally a Java class, doing regular Java things, like implementing interfaces, having constructors and fields, having public methods, which might be defined, declared in an interface and implemented in an implementation class, standard object-oriented design principles applied in a very idiomatic Java style, but managed by the Spring container at runtime, or as I prefer to phrase it, designed for management by the Spring container at runtime. At the source code level, this usually translates to some metadata added to your class in order for the core container, for the runtime container, to have some more formal insight into the intentions of your class. Basically, characteristics that are otherwise not expressed in the Java language itself can be added through annotations. So if you just look at this piece of source code, such a piece of source code, it is a Java class, having my bookadmin service as a name, but in this case, formally declaring itself as a service class, as an add service through an annotation on top. That's obviously better than a name, because it's a type, an annotation type that the compiler can check, And in particular, it is a formal characteristic that can be introspected at runtime. So the framework can actually find out that there is an add service declaration on top and make some assumptions about service classes in your code base. So back to the source code level, you're basically expressing the role of this class in a formal way. My book admin service is a service class. So if you just jump around a little, you can read a sentence from it, right? A public service class, a lazy public service class, right? Lazy is just an example for further characteristics that help the core container to react the way that you want it to react. Lazy suggests a lazy init characteristic here, lazy initialization. So for anybody creating instances of this class, initializing an instance of this class, initializing this component at runtime. Lazy is a hint. Please do it at the latest possible point. Don't do it on startup. That's what the usual translation of it. But fundamentally, it is a characteristic. This service class is lazy. This also translates to annotation naming here. Our naming is usually either a kind of categorization of the class here, or the method or the field, or it's a kind of description of the class or method or field or constructor. So that's the type level, right? At the method level, this transactional update book method here, it's just a regular service operation, relies on the state in our service class. In Spring, the state is typically, of course, managed by the Spring container. The Spring container, by default, assumes singleton scope, creates a singleton instance of this class. So you rely on the instance state, and service methods operate on it. The service method is annotated with @transactional here. @transactional, again, initially, is a characteristic, a description of that method, a formal description of that method. Update book is transactional. So the readability of the annotation serves it well here. You can again read this method signature if you just jump around a little. Update book is a public transactional method. @transactional, of course, at runtime has very concrete meaning. If you set up annotation-driven transactions, it means the container's by default going to create a proxy for your component here. It's going to intercept calls to update book, going to start a transaction before it enters the method, and committing or rolling back when the method completes. So there's always these kinds of two perspectives. The source code level, where some elements of your Java class are going to be annotated with certain characteristics, and there's always the runtime meaning, where the behavior of the runtime container by default reacts to those formal characteristics. All right. The annotation model is pretty sophisticated in Spring. And just a little hint towards what you can do with it. The annotation model is, for example, composable at the type level for custom stereotypes. A my service annotation, like just an annotation of your own created here, can use a meta annotation model to combine characteristics into one custom annotation. So custom annotations, for a start, are not that unusual, right? It's just a type added to your code base of type @interface. It's a little unusual to do it, maybe, but look at beam validation or other models out there that we typically work with. They have their own ways of using custom annotations. This is just along the same lines. So a custom my service annotation in your code base, of course, can combine custom characteristics. In this case, an add service, changing the default scope to session, having a default primary role. So if there's more than one match for any given type, this one always wins. So again, combining characteristics that are around in the Spring component model, even a default transactional rule, into one @myService annotation. Every time you're saying @myService on a class of yours, what you're really implying is the combination of characteristics above. So in that sense, in this storyline, this is a shortcutting model, but this is a little bit too practical almost, because it is, taking a step back, also a way to add a characteristic to your class again. The characteristic can have a custom name. It's named MyService here. Obviously, don't call it MyService. Give it a proper name, right? Give it a name which has a meaning in your code base, in your architecture, in your world, in the language that you're applying within your project. Maybe at order service, at account service, at something service. Just a descriptive name that has a meaning to you and your team. This custom annotation then sticks on a couple of service classes, formally categorizing them as this kind of special service of yours, implying the characteristics that can be found on the definition of this custom service type. In a regular IDE, you can just click on the My Service tab and you're going to immediately see the combination of characteristics on this custom annotation. So it's a very transparent declaration for anybody not familiar with it in your development team, maybe. Annotations are not just composable at the type level, they're actually composable wherever they are used. Just to give you other examples, for example, the custom transaction annotation down here, typically used at the method level, would be, well, it's called myTransactional here, could have a selection of attributes that it declares. Actually, that's the first feature. In composable annotations, you choose to redeclare certain attributes, but not others, which is a matter of guidance, or a way to guide the users of your custom annotations, which includes yourself in other parts of the code base, to just focus on specific attributes and not modify the others. Transactional has plenty of attributes, propagation behavior, timeout, isolation level, and so forth. With this custom definition, you're suggesting to ignore, to forget about all of those other attributes, to focus on a single one named read-only. And along the same lines, in the example above, you have a custom scoping annotation, which is quite common these days. Quite a few people define their own scoping annotations in order to have type-safe annotation names for particular scopes, not having to type the actual key of the scope, the session string. And again, this custom scoping annotation above has an attribute which it redeclares, the scoped proxy mode, from the Spring AddScope annotation. These kinds of attributes actually have a convention. So by default, there's a name-based overriding model there. But if you want to be a little bit more formal, which I strongly recommend, use an alias for annotation. It's a 4.2+ feature. As a side note, the alias for annotation can formally declare that a particular annotation attribute actually overrides a specific attribute on a meta-annotation. For example, with the scoping annotation above, the alias points to the scope class, to a particular attribute named proxy mode, and that's where the fine details of these examples start to appear. It actually renames the attribute, because the attribute's named mode here, and it overrides the attribute proxy mode. So with an alias declaration, you can change the name of the attribute, shorten it typically, to have a shorter attribute name on your custom annotation. With the example below, there's another little twist. The attribute name is the same. It's named read-only, just like in the standard Spring transactional annotation. But look closely. This one doesn't declare a default. The mode attribute above has a default. So if you're not specifying it, the default proxy mode is in this case no. In the read-only case down here, if there's no default, the Java language rules enforce a value. Every time you're using @myTransactional, the Java compiler is going to tell you that you have to specify true or false for this read-only attribute, because it doesn't have a default in the annotation declaration. This can be used for guidance again. If you want your developers, including yourself again, to reason about the read-only nature of a particular transaction scope, it's a good idea to have a custom annotation with no default here. It forces you to quickly think before you say true or false, instead of just implicitly having a default of false. Right, so much for a little bit of custom annotation design. We have a selection of pre-composed annotations as well in Spring Land these days. Of course, plenty of them are also in Spring Boot. The all at enable annotations and so forth, Spring Boot application, are all composed annotations in the end. Within Spring Framework, it's more about core component model annotations. And there were a couple of common requests. For example, to ship scoping annotations for the common web scopes out of the box, which we're doing now as of 4.3. But technically, those are simple annotations composed along the model that we've just been discussing. So at request scope is just meta-annotated with that scope, and it happens to have a default scope proxy mode. But that's the only difference, really. They are aligned in the sense of following the same design principles. If you disagree with the choices made there, just create your own version of those annotations. It's a completely open model. The only reason why we're shipping those out of the box is because people prefer to have some canonical annotations for very common use cases out there, instead of always redefining their own. And in this case, it's also about alignment with some other annotations in other Spring projects. There is already a refresh scope in Spring Cloud Config, drop and step scope in Spring Batch, pre-composed, regular add scope meta annotations on there. We're basically doing the same thing for the web annotations in the core Spring Web module. So that's a 4.3 feature, but actually the composability is a 4.2 level, 4.2 era feature. So continuing the story, configuration classes, most of you have seen them in one form or the other, I'm sure. They appear in Spring Boot in the full glory, but the core model, of course, is part of Spring Framework. There are plenty of features in there. We're not going to discuss them in any detail. Let's rather spin the story again. I'll continue the storyline here. Configuration classes are essentially pretty regular Java classes with a specific role, a special role in a Spring application. But fundamentally, they are regular components managed by the Spring container. They are annotated with add configuration, so they declare themselves having the special role of a configuration class. The container understands them like any other stereotype, like add service, add repository, add controller, it's add configuration here. It will create instances of your classes, of your my-bookadmin config class. So configuration classes can have instance state, field state, by default, singleton scoped, so shared across the application. The special nature of configuration classes is in the admin methods. Configuration classes typically are just a collection of admin methods. Fundamentally, those are methods declaring other or serving as the definition of another bean that's exposed to the container. So any such method declaration translates to a new Spring bean definition for the container. So if the container basically starts up, maybe does some component scanning if you're instructed it to, finds some configuration classes. For the configuration classes, goes through the admin methods, and for each of them, it creates yet another bean definition based on the declaration on the signature of that method. So for my bookadmin service, it basically knows the default name is my bookadmin service, derived from the method name, and it has a type hint on the return type here. So the reason why you should be reasonably specific for the return type of your admin methods is that the container during startup or during lazy initialization actually reasons about the return type. It doesn't have to create an instance yet to find out about the type, because your method suggests a return type that can be used for type matching. Admin methods can refer to each other. So like in this case, within the body of a particular factory method here, you can call yet another admin method to have a reference, a symbolic reference to that other component. We actually intercept those calls. So this bookadmin data source call to the other method is actually intercepted, goes back through the container. You will get the shared, managed, potentially proxied instance of that other bean returned to you. So it's not a straight method call, even if it looks like one. That's a special characteristic of configuration classes, and it's actually the reason why we create the glib subclasses at runtime, in order to intercept those inter-method calls. If you're not happy with the glib nature of those things, by the way, just don't declare it as at configuration. Use another stereotype, like at component, at service, whatever. Keep having the admin methods there. You will not get any glib subclass generation that way. But you also can't refer to the other method with that semantic anymore. So it's a somewhat complex, but also very comprehensive model. Configuration classes turn out to be very powerful. Just one thing to keep in mind. These methods here are all factory methods. So if all your components are trivial to create, if every time you're saying just return new my implementation class, there's a little bit of overhead here. You could just use component scanning, because for component scanning for a default component, we're going to look at the constructor signatures and going to call them by default. The real power of configuration classes is for non-trivial creation of instances, where there's a little bit of setup to do, some external, maybe factory methods or builder APIs to be called. And of course, those are factory methods. So the container is only going to call them when it needs to create a new instance. So for a singleton, that's basically once on startup, or once on actual use, if it's a lazy singleton, for the first actual use. For a scoped bean, we're going to create an instance every time the bean is actually used within a new scope, within a new session, for example. But it's factory methods, not lookup methods, from a conceptual perspective. So there are some other features as well, which we're not going to discuss to any detail, like the @enable annotations typically live on configuration classes to flag, to opt into some specific container behavior. And you can have conditions. In this case, there's this little profile example up there. Spring Boot is going much, much further in the use of conditions, reacting to the presence of classes on the class path, or to the non-presence of certain beans in your context definition. There's a lot you can do with this model. So we are only really tapping into the power here. Well, so much for configuration classes. Now, a few variants that you might not be immediately aware of. Configuration classes can have auto-wired arguments as parameter declarations. So if my bookadmin data service needs a data source in order to create its bookadmin service instance, you could, excuse me, you could call another method as shown before, but you could also say, I want this reference to my data source coming maybe from another configuration class. I want it right here in order to use it for building my new instance. Well, if that's what you want, and you want resolution at the latest possible point, consider using the parameter signature here. Otherwise, you could also inject it into a field of my bookadmin config and use it from there. This model specifically will only resolve the data source when actually creating a new my bookadmin service instance. If you wanted to have it in a shared field, in order to keep the container happy, you would typically have an auto-wired annotation on the field to use field injection, or on a constructor to use for constructor injection to inject the data source through the constructor and store it in a field. And then just use it in other method implementations, method bodies. Now, there's already the @autowired constructor commented out here, like in the initial example even. I didn't explain it at that time. That's actually this nice little photo 3 refinement coming in, and it's particularly useful, for example, for configuration classes and other classes which typically only ever have one constructor. If there's an explicit constructor, only one constructor for auto-wiring purposes. If there is only one, and we don't have any other information, any other construction rules, we're just now implying that you mean an auto-wired constructor here. So a commented out annotation means it's kind of nice if you put the annotation there in order for that declaration to be explicit, but you don't have to have it. The container, by default, assumes that you mean an auto-wired constructor. That's the case as of photo 3. So configuration classes can do quite a lot of things with standard Java language semantics. You can extend other configuration classes. You can create an inheritance hierarchy. So if a my application config extends a my bookadmin config, the my bookadmin config could just have some base admin declarations that you're inheriting in my application config, maybe adding some further admin methods at that level, and you only register my application config for a particular application context on startup. You could also have an abstract base class, kind of a configuration fragment, maybe with some abstract methods that the other configuration, the other method implementations refer to. You should actually do this here since there's a bookadmin data source reference, so this is a little incomplete. There has to be a declaration for bookadmin data source here. In any case, there are no really special rules applied here. This is standard Java language semantics. You just choose to use Java class inheritance, and the container, the Spring container, understands or translates those inheritance arrangements to its configuration class world. So you can override admin methods, you can have abstract base class methods implemented in subclasses and so forth, as you can with any other inheritance arrangement. And obviously, the most concrete version of a method is always going to be used. We can take this a little bit further to more unusual levels. What about Java 8 default methods? Meaning you choose to declare a configuration class, implementing an interface with the interface having Java 8 default methods, as suggested down here. Now, what would that mean, right? Well, it actually means exactly what you get out of the Java language rules for default methods. The default method kind of magically appears in your concrete class. It's inherited from the interface. It can be overridden, redeclared there, but it doesn't have to be. The runtime representation of default methods is a little bit weird, but the way that we are doing it is that we are kind of following the Java language semantics. If you have a default method declared with the admin annotation, what you obviously want us to do is to consider this method just like any other admin method in the inheritance hierarchy of a configuration class. So it's literally the same arrangement as if you would use an extensor arrangement. However, you're using interfaces. You can implement more than one interface with several default methods kind of inherited from several interfaces. So there's a kind of way to get multiple inheritance from several configuration base fragments. It's pretty useful in particular since default methods on interfaces can refer to regular methods in those interfaces, which can then be implemented by the classes. So you're getting an impression here already that you can take this model pretty far. Would we recommend building such complex configuration classes for typical cases? Not necessarily. The most important part is the design power. If you have a configuration scenario with this kind of natural inherent complexity in it, in the needs, in the flexibility needs for your configuration arrangements, then these kinds of arrangements, this use of Java language features within the configuration class model can be very useful. All right. Leaving configuration classes, moving on to the injection algorithm. We've already hinted at a couple of things, so that there's a type matching going on, type hints being used. Let's just focus on a few details of the matching algorithm. As of Spring Framework 4.0, the matching algorithm is based on a completely new implementation of a fully generic, capable algorithm. So we look at the full generic type declaration, if there is any, of the injection point, like my repository of account down here, and the declaration point, like my repository of account, for example, in an admin method. Fully taking this into account means that in case of ambiguities, if, for example, you have more than one my repository, like one of account and one of product, somewhere in your configuration classes. So keep in mind those are source code fragments. They're not complete, right? So they would live in some configuration class, maybe in a different corner of your code base. And in your My Book Admin Service class, you're saying, in the constructor, I want a My Repository of account. My Repository of account, of course, just looking at this can be resolved, right? There's a matching declaration up there. But at runtime, this is actually not as straightforward because generic type information can only be introspected in somewhat complex ways. But our 4.x level algorithm here finds primary type matches first, so it goes hunting for my repositories. And if there's more than one, it goes into the generic type declaration and finds assignable instances for your generic type declaration. So my repository of account can be, it's even the same declaration up there, but can also be matched, for example, against the my repository impl of account, or some implementation class which happens to implement the interface for my repository of account. So it's assignability, just like the Java language suggests it, just like the Java compiler would do it when you assign some instance to a variable of my repository of account. If the Java compiler considers it assignable, our algorithm considers it assignable. We even have a fallback for the so-called unchecked assignments. So if you want a my repository of account and the only my repository in the system is one without a substitution for the type variable, we even fall back to that, just like an unchecked assignment can be done in Java source code and compiled by the Java compiler. So again, just hinting at the power of the matching algorithm. The nice part here is that even for more complex arrangements, the type declaration in your signatures is usually, or like shown here, can be designed in a way where it is expressive enough to resolve the injection point against your bean definitions without any further metadata. There are no qualifiers here. I mean, in 4.3, you could even drop the Autowired constructor. It's not commented out here, but it could be. You can just drop it if there's just a single constructor anyway. So no annotations, no extra annotations added, no qualifier information added. Just looking at the type signature and trying to apply Java language semantics to find out about the runtime arrangements. Right, a couple of variants, quickly going through them. Maybe you haven't actually seen that kind of arrangement before. You can inject a list of, for example, my repository of account even. You can ask the container to find all the matches and build a list for you. And this even works with generic type declarations. To any level, the matching algorithm can resolve type information, type variable substitutions to any level. So it's a list of my repository of account. The container is going to find all the my repository of account beans in your context, build a list of them, and pass them into your constructor that way. And as of recent Spring generations, you can even order beans. If you assign an order value to your bean definitions within the set of type matches, within the my repositories here, the list will even be pre-ordered according to the order values. The container is going to build a pre-ordered list for you. So there's a lot of sophistication in the matching algorithm here. As of 4.3, you can also declare beans, for example, as a list directly. There could be a bean which is declared as a list of account and an injection point down here asking for a list of account. So if there's no individual account beans, previously we would only have looked for those. We also accept a list of account bean. Of course, that's going to be injected as is. It's also a commonly requested feature, declaring lists or maps or sets as a bean type and injecting them in a raw form directly. Possible as of 4.3 without any further dancing around it. So it works basically without any extra metadata as of 4.3. Right, so to wrap up variants of injection points, a nice little more recent feature is lazy, the use of lazy at the injection point level. Add lazy can be used at the declaration point, can be used on component classes if it's a class that doesn't have a factory method for it. It can be used on a factory method, like an admin method above. That's already pretty well established. It basically just means if the scope has a lazy init semantic, apply it. In singleton scope, it means create the instance the first time somebody asks for it, and not on startup, please. But what about add lazy on an injection point? A lazy my repository of account. Well, this is a hint to the container that you're not going to use that given reference immediately, which is actually pretty common if you think about it. The component asks for this reference, but it's just going to store it, probably in an instance variable of some kind, and it's only going to call methods on the given reference in some service method implementations later on, when actual service calls come in. Add lazy formally expresses that that's the case. You're not going to use it immediately. You're happy accepting a reference to a not yet initialized target bean, not fully initialized bean yet. The standard semantic for injection points is, I want a fully initialized target reference. Lazy basically expresses actually the almost more common semantic of, I'm happy with any reference as long as I can call it later on. This can be used to resolve quite a few scenarios. Startup timing scenarios, circular reference scenarios even. Circular references are only a problem if both sides of the reference insist on a fully initialized counterpart. The moment that you use lazy references, it's becoming a trivial situation, basically. So that's add lazy on the injection point. Note the use of a parameter level annotation here. Shows up in quite a few Spring examples these days. This is a nice one as well. What's lazy here is the actual my repository. That's why we annotate the parameter. If there's several parameters, because you're asking for several dependencies in this constructor, you can individually choose the laziness for any given parameter. You can annotate each individual parameter, or not annotate it. So it's a characteristic of the parameter, not of the constructor. All right, just for completeness, there's a set of standard annotations that can be used instead of the annotations that I've been showing before here. You can use, for example, the managed bean annotation from javax.annotation for a component declaration. You can use the add-inject annotation from javax.inject for an Autowired declaration as an alternative to Spring Set Autowired. And there's several other standard annotations that we support in the component model. The point of this mentioning here is you can choose to use standard annotations as a characteristic, as a way to express a characteristic in your source code. At runtime, the Spring container just implicitly understands those. So to the Spring container, it does not make a difference whether you use add Autowired or add inject. Two ways to describe a characteristic in your source code that the container can react upon at runtime. You can also mix and match them. There's no exclusivity here. You can use add inject in one place and add Autowired in another. As a recommendation, stick with one set of annotations. And the most powerful set of annotations certainly is the Spring set of annotations here, because they are composable, because they have several attributes usually to fine-tune the behavior. But if you're happy with simpler standard characteristics, maybe for reusable components that are reused across several projects of yours, this use of add inject in particular is actually pretty common and a worthwhile choice. All right, another little use of standard types goes into Java 8 territory now. So look at that signature for the constructor. This constructor actually asks for an optional of my repository of account. That's Java util optional. It's a nice little twist where we are using the Java util optional type in Java 8 to express the optionality, then the dependency declared as not required. So if you declare optional of my repository of account, the Spring container understands that the Java util optional type implies that the dependency doesn't have to be there. If it's not there, you get an optional empty. If it's there, you get an optional with the actual repository reference. So no further metadata, no further configuration needed. Just your Java source code doing Java 8 language things here, which can be used at runtime to infer some characteristics for dependency injection purposes. Of course, this also works with Autowired, but it's particularly nice in combination with inject, where there are no Spring imports in your class, in your source code to suggest those characteristics. So there's quite a lot you can do at the injection point level. But to wrap up this little tour, let's move on to the endpoints. In the endpoint design, where we're actually using the endpoint term in a pretty broad fashion, right? Endpoints can be HTTP endpoints, can be messaging endpoints. The endpoint design follows a certain design model as well, kind of related to the core component model, but applied to the idea of handler methods at the endpoint level, at the boundaries of your system, endpoint methods being bound to incoming requests, incoming messages, some kind of incoming payload that needs to be handled. The most common variant of it, of course, are NVC controllers. So this is, I suppose, common, familiar to most of you. NVC controllers are, again, regular Spring components. So a regular controller implementation is a Java class, will get instantiated, typically with singleton scope, can have field state, has a controller stereotype on top, can express other characteristics at that level, and has mapping annotations. In the MVC case, typically request mapping annotations. Request mapping, here with two kind of REST-oriented cases, having a lot of capabilities, like the extraction of path variables, or the idea of calling a validation engine before we pass it into the handler method. All of those things can be expressed with now common source code elements. So there's nothing unusual here from a Spring component model perspective. Type level annotations, stereotype, mapping annotations, and type level annotations. Particularly common for handler methods. So path variable, suggesting that this ID needs to be resolved as a path variable of the same name in the given path. There's also request header, request param, cookie value. It's a little bit related to the dependency injection arrangements. We're not injecting dependencies here. We are extracting certain values from the incoming request. And each individual parameter says what it wants to extract, what it wants to be bound to. So a request comes in, the dispatcher calls the method, resolves the parameters, and calls the actual body. For MVC controllers, that's pretty straightforward. So this is the common style that we've seen over many years now. As of 4.3, there's a pre-composed variant, because request mapping annotations are composable, like almost any other annotation in Spring. So you can create your own version of the annotations, redeclaring some attributes. It's not particularly commonly done, but we're doing exactly that as of 4.3. So that's the same controller using a precomposed set of annotations, in this case add get mapping and add post mapping. We have precomposed annotations for all sensible HTTP methods now, so for everything but trace and options, and also not for head, because the get mapping implies head in the servlet world in many cases. So it's a little bit restricted in comparison to request mapping. It cannot express the full power of mappings, but it's very close, and it's very practically oriented, because in most cases what you're binding to is exactly based on the method and a particular path, on the HTTP method and a particular path. Now, if you compare those two examples, the request mapping one is a little bit, well, more wordy, more noisy, because you have to specify in the Java annotation model, you have to specify the attribute names. You have to say request mapping path equals something, comma, method equals post. And this already has a static import for the request method, enum here. So it doesn't really get much shorter than this. Because of the Java language, because of the Java annotation model, if you specify more than one attribute on an annotation. Now, if the annotation design implies the HTTP method, because get mapping and post mapping in their design, in their naming of the annotation type itself imply the HTTP method already, there's typically only one attribute left to be specified, which is the path. If there's only one attribute specified and there's a value declaration on the annotation, the Java language says there's no name to be specified because there's only one value and it goes kind of to the default attribute. This only works if you only need to specify a single attribute. So that's kind of the motivation for the design of those. For the very common cases, we significantly shorten the declaration in alignment with the Java language annotation model. Right, so just a quick question. Who prefers those versions over those? Who likes the get mapping, post mapping ones? Oh, sorry? If you have to be, there are actually attributes on get mapping and post mapping for the producers and consumers conditions. You can specify almost everything you can do on request mapping. But some of the benefit goes away then, because if you have several attributes, you have to specify the names of those attributes. It's still nice, it's still shorter, but kind of the full conciseness you only really get if you reduce it to an attribute only. But get mapping and post mapping are almost as expressive as the regular request mapping. So anything you want to do, any further conditions you want to apply, any MIME types you want to specify, you can still do it. It's been quite, I admit this has been quite hotly debated among the team, but we generally feel that they are a nice compromise between more specific annotation types and the conciseness benefits here. The runtime behavior is exactly the same. Those are just annotations with at request mapping as a meta annotation. You could create your own versions of those. It's almost trivial based on the annotation composition model that we discussed before. You could shorten the names to add get and add post if you prefer, right? But in the Spring world, we prefer this mapping suffix in order to have a clear arrangement for the kinds of methods that this is to be used on. So, to wrap up the story, there's a consistency in our endpoint design, which also shines through to other models. And we're not going to go into the specifics of what happens here, but just an example. If you want to bind to stomp messages coming in on a WebSocket channel, this is what a controller typically looks like. Almost like an MVC controller, actually specific mapping annotations to either stomp subscribe requests or to regular stomp messages. We're using specific annotations for those, binding to a particular stomp message path. So, different world, really. The stomp messaging protocol, different kind of channel. We're not mapping to HTTP endpoints here, to regular REST-oriented endpoints, but a very similar arrangement in terms of what the controllers look like. This goes quite a long way. As a related example, this is what JMS listeners look like. If you want to use handler methods and bind them to certain JMS messages, JMS suggests a listener model, and we, as of 4.1, support a pretty flexible, pretty powerful arrangement through the @JMS listen annotation. There's a nice short variant above. This is what the ideal JMS endpoint binding would look like. But we know that JMS is a complex topic, so we allow you to be as specific as you need it to be, as indicated by the example below. There are actually plenty of attributes on there. The design of those endpoint methods is very similar to the MVC endpoint model in the end. All right, and last but not least, we have event listeners. Event listeners actually process typically application internal events, application events published from one component to a set of other components. We have an event listener model looking almost like JMS listeners again. So we are striving for consistency here in the way that those kinds of callback methods are declared, always with a flexible parameter signature, typically indicating a payload, possibly referring to a particular header through an header annotation here. So from a design perspective, we are trying to make them as analogous as possible, as similarly structured, with common design elements shining through, even if we, at the same time, we bind to a particular kind of request, message, or event here. So it's a kind of compromise between design consistency at the source code level, but binding to a particular target without trying to abstract it. So the full power of HTTP bindings, JMS bindings, event bindings is available to you with a consistent design model behind it. All right, that's basically a bonus caching annotation. So if you want to use caching just like you use @transactional on any given methods, this, as you would expect, looks very, very analogous without us discussing the details here. And we even support, as of 4.1, the standard caching annotations as part of our story that we hinted at before. If you choose to use javax.star annotations, the Spring container implicitly understands them, processes them the same way or as analogously as possible as the Spring set of annotations. So that's basically the end of this little design tour through the Spring component model and some of its characteristics, some of its more recent specialties. This is at 4.3 level. Some of the things are like the precomposed mapping annotations, the precomposed scope annotations are new in 4.3. And as we've already heard this morning, 4.3 is going GA in, well, just a couple of days, really, in early June. So it's going to be available at your fingertips very soon now. Thanks for your attention. If there are any questions, I'm happy to take them. Just come up individually. Happy to discuss any of the design here. So thanks for the attention. Enjoy the rest of the conference.